Yes, sir.
Okay. Okay. Students, today we have on video session also. Okay, you can see the basic concepts as well as Unit 2 as well as Unit 3. Okay. It will be useful for all the topics which is in our syllabus also. Okay. So it will be a simple demo for how they are going to present this particular topic. Okay. So before that we will see what are the topics to be discussed in Unit 3 as of Unit 3 is concerned. Okay, we'll have a small outline of what are the things to be seen in Unit 3. Okay, so in Unit 3 we are going to see transaction concept. What are the different transaction, how the transaction can be made, whether the transaction is abort or if it is abort means again a new transaction has to be made, all those things. Okay, then the asset properties, then schedules. Based on different schedules, we are going to check with the how the particular A or B is going to quit the job to be done. Okay, then serializability, then concurrency control and the need for concurrency, blocking protocol, two-phase locking, deadlocking, transaction recovery, save points, isolation level, as well as SQL facilities for concurrency and recovery. Okay, so these are the topics which are going to be involved in Unit 3 for the topic is concerned as transactions. Okay, so generally what is called transaction? So from one place to another or from one account to another account, if your money is going to be given from one account to another account or debit or credit, whatever the thing it will be, so that is also a transaction. Here also we are going to see what type of transaction is going to happen and with the different ideas behind the transaction concepts, asset properties, schedules, lockings and all these things. Okay, so before moving to the topic, we will see a small video session regarding what are the basic things, that is keys. Okay, so there are different keys, right? Okay, so we'll see the keys and we'll move to the session again. Okay, there are some concept in basic concept of DPMS, that is superclass, subclass, primary key, candidate key and foreign key. For Unit 2, we'll have a small video session for 8 minutes. Okay, approximately 8 minutes. Okay. Yes. Okay, can you able to hear the voice, ma? Yes.
No, sir.
Voice கேக்கலையாப்பா? ஒரு நிமிஷம். இப்ப பாருங்கம்மா. இப்ப வாய்ஸ் கேக்குதாமா?
Yes, sir, but low.
Loud இல்லையா? ஒரு நிமிஷம்.
Let's take an example. In the table above, we have SID, this concept, as there are many different kinds of DBMS keys. And hello friends, welcome back to Study Tonight's YouTube channel. In this video, we will talk about DBMS keys. Students are always confused about this concept, as there are many different kinds of DBMS, and almost all are related to each other with a slight difference, which makes it very difficult at times to get clear understanding.
இப்போ ஓகேமா?
Students are all Students are always confused about this concept. In this video, we will talk about DBMS keys. Students are always confused about this concept, as there are many different kinds of DBMS keys, and almost all are related to each other with a slight difference, which makes it very difficult at times to get a clear understanding. In this video, we will learn what are database keys, why we need these, and the different types of the DBMS keys. A database key or a DBMS key is an attribute or a set of attributes which help you uniquely identify any record or row of data in a table. Let's take an example. In the table above, we have SID, SNAME, SBranch, and SEmail as attributes, saving details about students. If I ask you to tell me email address of the student with name Adam, can you tell me? No, because there are two students with name Adam. Or if I ask you tell me name of student who is in CS branch, again there will be many students in that branch. But if you look closely, SID column has unique value. The SEmail column also has unique email addresses, and these two columns can be used for table. So we can say that SID and SEmail are keys for this relation. This brings us to the question, why we need keys. The first reason is pretty much obvious. Without a DBMS key, you cannot access the rows of data stored in the table uniquely. Because without a key, most of the time you will either receive multiple rows of data or incorrect rows of data. Another big reason, which is kind of an extension of the first reason, is we can force identity of data and ensure integrity of data is maintained using DBMS keys. By making an attribute a key and making it mandatory, we can enforce that anything inserted in the table is identifiable, hence ensuring data integrity. And last but not the least, we can establish a relationship between tables using keys. It's time for the main event, types of DBMS keys. There are 8 different types of DBMS keys, of which super key is like the default key, and composite and compound keys are like cousin sisters. We'll see when we learn about them. So we will be starting with super key, then we will move on to candidate key, then primary and alternate keys, then the foreign key, which is different from all others and serves a purpose which none of the other keys do, and then we will cover the remaining keys, which are composite, compound, and surrogate. Super key is nothing but a key. It is a superset of keys in which all possible keys are included. Like in our example, SID, registration ID, email, then combination of them, SID, registration ID and email, email and SID, and then all three together, SID, registration ID, email, all are super keys. There can be more as well. In simpler words, an attribute or a set of attributes that can be used to identify records in a table is a super key. Then comes candidate key. It is the minimal set of super key which can be used to easily identify rows of data in a table. We saw that we have so many options for super keys, but most of them are formed by unnecessary pairing of keys, like email ID, SID, registration ID together as a key, or email SID as a key. When email, SID, and registration ID can individually uniquely identify a row of data. Hence, in this case, the 3 attributes SID, email, and registration ID or reg_ID.
voice
super key, hence the candidate keys. Speaking books language, if any proper subset of a super key is a super key, then that cannot be a candidate key. Now let's try to understand this. Registration ID, email, and SID together form a super key, while email and SID is a proper subset of it and is also a super key. Hence, this is not a candidate key. Similarly, email SID is a super key, and its proper subset, email and SID, both can act as a super key individually. Hence, this is not a candidate. This way, we can come to a conclusive proof that SID, email, and registration ID are the candidate keys for the relationship that we have. Now, moving on to primary and alternate keys. A primary key is a candidate key which is used to uniquely identify every row of data in a table. Now, you must be thinking that we have 3 candidate keys and all of them can do so. Well, in that case, you can make anyone a primary key. This is generally done by database administrator to set a candidate key as a primary key. If we have to create a simple user interface to search for student information for a college using the table in the database that we have as an example, what will make more sense? SID, which is an auto-incremented value by the database itself, or registration ID, which every student knows and is more meaningful for college administration too. Hence, in this example, we can make reg_id or registration ID as primary key. All the remaining candidate keys which are not selected as a primary key are called alternate keys. Now, coming to foreign keys. Foreign key is nothing but an attribute in a table which is used to create a relationship of that table with some other table. In case our tables have relationship, using foreign keys helps us to maintain data integrity for the relationship. For this, we will have to involve another table in our example. Let's say we have one more table, branch, with information about the branches in the colleges. It has a unique column with branch code, branch name, HOD, and some more branch-related information. In the students table, the branch code can be made a foreign key to set up referential integrity or relationship between the table student and branch. This way, while making a new student entry, a wrong branch name cannot be provided, else a DB will return error. Similarly, if someone deletes a branch entry or updates a branch code in branch table, they will have to change the same in students table too. Generally, this is not allowed by the database, and the database returns error when someone tries to modify the column value which is used as a foreign key in some other table. Hence, this way we can force integrity of data in a relationship using foreign keys. Moving on to the remaining keys, a composite key has multiple attributes. Hence, all the super keys with more than one attribute are also composite key. In our case, email SID together, SID registration ID together, registration ID email together, all are composite keys. If a composite key has one attribute which is foreign key, then it is called a compound key. Moving on to the surrogate key. Sometimes a relation or a table has no attribute which can uniquely identify the rows in the table. In this situation, when there is no natural primary key, we create an attribute to act as a primary key. That is a surrogate key. These keys do not add any meaning to the data, but serves the sole purpose of identifying the data. With this, we have covered all the DBMS keys, starting from super key, candidate key, then primary key, alternate key, foreign key, composite and compound key, and surrogate key. I hope after watching this video, you have a better understanding of what DBMS keys are, why they are required, and the various different types of DBMS keys. If you like this,
Hello my dear students, today I will discuss about one more important topic of database management system, that is DBMS, transaction processing. So let us start. What is transaction? Transaction is defined as a collection of jobs, or in other words we can say that transaction may be defined as a group of tasks that is to be performed by a user in a database. In other words, transaction is a unit of program execution that access and update various data items. Various data items that has been updated or accessed or retrieved within a database with a unit of program execution. Or in other words, we can say that transaction is nothing, it is a result of execution of user programs that are written in high-level data manipulation language such as SQL or high-level programming language such as C, C++, etc. In a very just or crisp, we can say that a transaction is nothing, it is a program in execution. Right? For example, suppose in a bank, let T1 be a transaction which is basically used to transfer fund or amount from one account to another. This is called a transaction within a bank. So there are some stages or states of transactions. Transaction in database can be in one of the following states. All the states can be lie in between start and close of transaction. Start or begin or between end of transactions. So first state is called active state. Active state means that transaction is being executed. Then next is partially committed state. Partially committed state means that transaction is executed its last operation. You know that transaction consists of various operations or instructions. So it is executed its last instructions or operation. Then transaction executes all its operations or instructions and transaction is saved onto the database. While in case of partially committed or active states, transaction is not saved into the database. And then finally, we close the transaction or end the transaction. Another state is called failed state, which states that a transaction is being failed due to one reason or any other reasons. It may be either through active state or through partially committed state. And then transaction is terminated, completes its task or aborted, and finally close its execution or end its completion or task. So let us discuss this in brief. So we have first stage called active state. Active state states that the transaction is being executed. For example, when we are trying to insert or update data into the database in any format. Then second is called partially committed, means transaction is executes its last operations. Its last operation means there may be n number of instructions within a transaction, and the last instruction is transaction executes its last instruction or operations. That is a part of partially committed state. Then committed state means transaction executes all its operations successfully. Means all the instructions within a transaction completes its task successfully. And failed means a state is called a failed state if any of the checks made by the database recovery system fails. So it means that failed transaction may no longer further proceed at all when transaction fails. Then finally terminated, or also known as aborted. Transaction once the transaction completes its execution, it will terminate it. And there are two operations to be performed in it. Number one is called rebegin or restart of transaction, and number two is called destroy or kill of transactions. This is called termination or terminated state. So next is operations on transactions. We can perform major two operations on transactions. Number one is called read and number two is called write. Read operation states that it is basically used to read a data item X from the database and store it into a main memory for operation, for performing any operation on it. And write operation means once the operation completes its execution, write operation is basically used to write the value back to the database from main memory. It means read X means read the data from database to main memory for execution, and write X means once the transaction completes its execution, it will its value will back to the database from the main memory, right? So let us understand this with the help of an example. Suppose X and Y be the two accounts in a bank, and let transaction T1 is used to transfer rupees 100 from account X to account Y. So it may be defined in this format. Transaction T1 will first read that data item X. X is an account. Read X means it will read the value of X from database into main memory, and then it will deduct ₹100 from X. So suppose that the value of X is initially 5,000. Now after deducting ₹100, it will give a value 4,900. And then finally, once this operation has been performed, the value can be rewrite back onto the database with the help of write operation, that is write X. So final value is 4,900 after deducting ₹100 from it. This is for transaction. This is for account X. Similarly, the second account is called account Y. Will read value of Y in the sense that will read the value of data item Y from database into main memory, and let the value of Y is 6,000, right? Then on account Y, that ₹100 will be added. Y is equal to Y plus 100. Now the value of Y is 6,100. And finally, after performing this operation, we'll use write operation to reback the value of Y from main memory to database. That is with the help of write by operation. Now the final value of Y is 6,100 rupees, right? So it is important to note that before execution of this transaction and after execution of this transaction, the value of X and Y must be consistent, or the value of database must be consistent. It means suppose before execution we know that the value of X is 5,000 and the value of Y is 6,000, right? Now X plus Y, we have 11,000 rupees, means account X and account Y now contains 11,000 rupees before execution of this transaction. Now second is after execution. After execution of the transaction, the value after execution of this transaction, the value of X becomes 4,900, this one, and the value of Y is 6,100, that is this one, and the final value of X plus Y is 11,000 rupees. It means before execution of this transaction and after execution of this transaction, the value of database remains same. The value of database remains same means that database is in consistent state, that is in correct format. That's all.
Okay. Now you have seen some video session regarding what are the keys, what are the different types of keys, and how the keys are going to be useful for primary, secondary. Okay, so all these things. So that particular slide will be shared to you. Okay, so I will share the slide also to you in order to have a clear idea. So we will have a discussion regarding Unit 3. That is transaction concept. That is the first topic. So we'll have a discussion. That is, so what's called transaction? So transaction is nothing but it's a collection of operations. So collection of operations means there will be a different set of work will be, or a different set of data will be there with a different logical structure. All these data are collected in the single logical unit. Okay, that is a collection of operation, right? So from where the data is being collected, how the data is being collected, we have to check all these things. So there is a simple transaction example, how the account balance is checked. So your read account, how deducting the amount and writing the remaining balance of your account. Reading the friend's account, how much balance it is, then the amount which is account balance, as well as updating the balance to the account, and operations. The whole set of operation can be called as a transaction. So all the operation behind this in a simple transaction. So all the operation behind this is called as transaction. Okay, so the whole set of operation is called as a transaction. Now, okay, now, so transaction process processing systems. So what are the different transaction processing systems? So a system must have a database. So in a database, there might be hundreds and thousands of users are there. Okay, so all the user must get the data, whatever the data it is, whether it is a small data, large data. Okay, they have to get the data from that particular concurrent users. Okay, so now we are going to execute this particular database. So a simple transaction processing system will be happen now and then in a reservation system or banking system, other system also. Okay, so it's a reservation system in the sense a flight reservation, train reservation. Okay, and banking system in the sense a different account transaction and account need, all those things. Okay, you might have done a reservation. All of you known regarding the reservation, how the process is and what are the different set of process and how this transaction will be made, all those things. Okay, so we are going to see a simple example for that reservation system or banking system also. So that might be a suitable one for the transaction processing system. Okay, so in this transaction processing system, we have concurrent access. So what is called concurrent access? So before moving that one, MCQ from MCQ part. So we have a transaction processing system. That is a very important one. Okay. The next one is concurrent access. So concurrent access means we have a multiple users. So the multiple users are going to access a system at the same time. So if one user is going to use, then we can use the system at one time. So if a multiple users are going to use, then we have to do a multi-programming test. Okay, multi-programming test. So in that case, we have a parallel multi-user access also. So that particular user can access multiple resources at the same time. Okay, a particular person or user can access different resources at the same time. Okay, so the concurrent access also will come in a MCQ question, get to it. Okay, next. So here is a simple example how this transaction concept is going to be implemented. So there are A and B concepts are there with different time limits T1 and T2, where the CPU from first, second to nth CPU is there, where the transaction limit or time limit between A and B, how the transaction is going to happen is shown. So there is a interleaved multi-user access to a single resource based on time. So T1, this T1 will take this much of time for this particular A and B, and for T2 this much of time is going to take for the A and the B from CPU 1 as well as CPU 2. So there are multi-users. Okay, if more than 2 users mean multi-users, where that particular access is going to happen in a single resource. Okay, based on the time T1 and T2. So this is how the transaction concept is going to happen. Okay, ma'am. So now if there are multi-users, as we said, so there are based on different time limits and different process, different sectors, other A and B, based on a different time limit, the process is going to be handled. Here the transaction access having a data using 2 operations. So for A, T1 and T3, another A is there. Okay, 2 operations they are going to carry. Example, in the video session also you have seen read of X and write of X. Okay, so what is this read and write? Okay, so you will see that one. If transferring the data item X from the database to a local buffer, I am going to transfer the data item X from the database to a local buffer. So how I am going to transfer? So based on executing the read operation, based on read of X, I am going to transfer the item X from the database to a local buffer, Okay, so that is the first one I am going to do. Second one, so first I have read that particular transaction. Now I have to write. So write of X. If the particular item X from the local buffer of the transaction, this is from the database to a local buffer. Here from local buffer of the transaction to the database. Getting it? So this will surely come in a MCQ. Okay, so reading from database to local buffer, that is read X, and the item from local buffer of the data to the database is called as write X. So the write will have a back to the database again. Okay, so it actually transfer the data item X from the local buffer of the transaction to the database. Okay, from the local buffer of the transaction to the database, that is called as write X. And read X is a particular data item X from the database to the local buffer. Okay, executing from the database to the local buffer. So that is called as read option. Okay, so these are the two options which is available in the transaction concepts. So in the MCQ you can very much you can check with these transaction concepts and you can get to it. Okay, so there are multi-user. So what are the things we have seen? So today we have a video session regarding transactions as well as what are the different types of key, primary and foreign, and different types of keys. Okay, so those two video session, I think it might have given some more idea regarding the concept. And today we have started the initial thing, that is transaction concept in the transaction unit 3. Okay, so what are the things we have seen? The video sessions as well as here transaction concept. So a transaction is a collection of operations. So what is the transaction is called? It's a collection of operations. What are the operations? So from it has a logical unit of work. So for that one we have a simple transaction example, that is read, detect, write, read from your friends and the amount and write the new updation as a whole set of operation. The whole set of operation is called a transaction. So a simple transaction example also we can have a form of single logical unit of work. Okay, so next one, transaction processing system. So there might be hundreds of users where a large database system in that data can be executed and the transaction can be made. Okay, so for that one a better example is reservation system as well as banking system, where the transaction will be made on a regular basis from one end to another end. Okay, so a large number of customers or hundreds and a large number of customers can have transaction using this system in large database. Okay, next, concurrent access. So a concurrent access will have multiple user accessing system. So multiple user means at the same time many user can access. Okay, if it is a one user means it is a single user. If it is a more than two users means it's a multi-user, where the system at the time itself they can achieve by multi-programming. Using a multi-programming method they can achieve this multi-user system. So a parallel multi-user can access different resources at the same time. Okay, so here also there is a simple example where it is interleaved, that is multiple access from A and B using a different time limit. So two CPUs having different access by the multiple users and having a single resource based on time. Okay, single resource based on a time. So A is one resource and B is one resource. Here, two resource using two operations. Transaction using two operation. For A itself, two operation, and B is a two operation under different time limits. So first one is how the access is going to operate this two operation is. One is read X. So read X means the data item X from data to the local buffer, and the write X means the X items from the local buffer of the transaction to the database. So it write back to the database again. Okay, so these are the two transactions. So next we will continue in the next session. Okay, so we will take the attendance first. Okay, for Harsha is there? Okay, Harsha, just send the A section attendance. Okay, and what about Punidan? Punidan is there too? Punidan? I think mic issue is there. Okay, I will take the attendance then. For B section, A section will be there. Okay, answer your attendance, ma. Parandaman is there?
Yes, sir. Yes, sir.
Okay. Pawan Kalyan?
Yes, sir.
Okay, Pavitra? Pavitra? Okay, check with Pavitra, ma. Okay. Pragadish? Pragadish? Okay, Pranish? Prashant? Okay, I think some mic issue is there. Okay, Pranish is present. Okay. Okay, Pranish present. Prashant, what about Prashant? Okay, no idea. Preeti G. Okay,
present,
both the Preetis both the Preetis are present. Prem Kumar.
Yes, sir.
Priyanka is present.